My name is Colin Gilchrist. I'm the Technical Director here at eapprentice, and I'm joined today on the line by Derek Goodwin, who's the founder. And today we're going to talk about gap settings. So our agenda is, what is a gap? We're going to define our terms. We're going to talk about gap distance and defining the gap value. We'll go over the gap settings. And finally, we'll finish with the role tool settings and some practical examples. So what is a gap? Let's go ahead and define some terms. Gaps are the spaces between slices when a toolpath is calculating the motion across or along a surface. Gaps control retract and reposition behavior between the cuts on a surface toolpath. And defining a gap is done by either a gap distance or as a percentage of the tool. Switch over to Mastercam. We're looking at Mastercam version 8. And this is a simple, flat, rectangular surface that I've created. I'll rotate the view just a little bit. And this is just a 3x5 rectangular surface. And I've put down a surface finish parallel toolpath. I'll open up the parameters for the surface finish parallel. And on the finish parallel parameters page, we'll be looking at the gap settings located here in the middle of the dialog box under this button that says gap settings. When I click on that, that's going to bring up our gap settings dialog box. Let me switch back to the presentation real quick. So what is a gap? Gaps occur at the end of a slice. A slice is calculated as the surface and plane intersections occur. At the end of the surface and plane intersections is the start of the gap motion. The gaps in our toolpath will vary depending on a variety of factors. Step over value of the toolpath directly affects the gap distance that's created. Cutting method, zigzag or one way, can really affect how the gap distance is applied. And then the gap size value itself. There's a setting that we can enter a size. So to really sum it all up, gap definition. A gap in Mastercam is the distance from the end point of one toolpath slice to the start point of the next slice. The gap settings control tool retract behavior. If the motion is less than the gap size, it will keep the tool down in contact with the surface, and there are 4 methods. And when the gap distance is exceeded, the tool will always retract. So really the gap settings control the retract behavior of the tool when you're cutting on a surface. So gap settings. The gap settings dialog controls several related sections. First, you have the gap size. This is where we define the gap. If I switch over to Mastercam, in the gap settings dialog box, you'll see that these options are broken down into sections. So you see right here it says gap size, and there's a faint gray outlined window that goes and surrounds the settings that are part of the gap size definition. So the only 2 settings that are in the gap size are distance or percentage of step over. So this first setting here is really critical. This first setting tells Mastercam how we want to define our gap size. Do we want to use a physical distance value, or do we want to use a percentage of our step over value? The step over value is actually defined on the Finish Parallel Parameters dialog box. So right here it says max step over 50 thousandths. And what that is doing is taking our tool and stepping over 50 thousandths of an inch per slice or per pass on that surface. So I'll close out of these dialog boxes, and let's go and kind of zoom in near the origin here. As we zoom in near the origin, you can see that we've got our toolpath displayed on this surface, and about every 50 thousandths of an inch, there is a slice or a pass that's being made on that surface. This motion right here is the connecting motion between slices, and that is controlled by our gap settings. I'll go back into the surface finish parallel parameters. Right now my max step over is 50 thousandths of an inch. If my gap size is less than the distance between my slices or passes, my tool is going to retract. So depending on the gap definition, which is the gap size right here, Mastercam is either going to use this section that says motion less than the gap size, keep tool down, or it's going to use motion is greater than the gap size, retract. So once we define the size of the gap, if the motion of our tool is less than that gap size, the tool is going to stay down on the surface. If the motion is greater than that gap size, then the tool is going to retract. And we can show that without even adjusting the gap size, just by changing our cutting method. If I change my cutting method to one way, and I regen that tool path, we can see that the tool, if I go into backplot, and I'll start stepping through that motion, the tool retracts at the end of each slice, because currently our gap settings tell it to. I'll go back in the parameters, hold on one second, everyone. Okay, so I'll go back here, and if I go to my gap settings, and instead of defining it as a percentage of my step over, which right now is 3 times my step over distance, or 150 thousandths, I'll instead set my gap size to a physical distance. This surface is about 5 inches long, so I would expect the distance from the end of one slice to the start of the next slice, since it's on a slight angle, to be just over 5 inches. If I make my gap distance 10 inches, my gap size is now greater than the distance between these slices. So what the toolpath calculation is going to do is keep that tool down. So each reposition to the start of the next cut is actually a angled move that stays down on that surface. Let's go back to zigzag for a moment. If I'm using the physical distance setting, and my physical distance is less than that max step over, let's say 0.02 instead of 0.05. and I regenerate that toolpath, Mastercam is going to cause the tool to retract at the end of each slice, even though we're doing a zigzag style motion. So if we look at that in backplot, we will get what I like to think of as the sewing machine effect. And this is where the tool is basically retracting and then reapproaching the part at the end of each slice and the start of the next slice. I'll switch back over to our presentation for a moment. So under the gap size, that section defines the distance between the slice points. You can either use distance or a percentage of the step over. So one is an actual physical distance value. The other is a percentage of your step over value. And this is the main setting that controls your gap motion. You must set your gap size, or when you notice that your tool is retracting where you don't want it to, you must go in and at least change the gap settings to get the type of motion you want along those surfaces. Now, if the motion of your tool is less than the gap size, those are the settings that control the method. So when the motion of the tool is less than the gap size, the tool is going to stay down on that surface. And it's going to do it using one of four methods. I'll switch back over to Mastercam and go into the parameters, and we'll look at gap settings. So if the motion of the tool is less than the gap size, the tool is going to stay down on the surface using one of the four following methods. Direct means we will connect the endpoints here in a straight line, essentially. So it's just going to go from the end point of a slice to the start point of the next slice. Direct can be a little dangerous because depending on your gouge checking settings and the shape of the surface, you may have a case where you get a gouge into your surface that's caused by the gap motion. Broken allows the tool to move independently in X, Y, and Z. And it depends on whether the tool is going down a surface or coming up a surface. But if it's going down a surface, the tool is going to move over in X, Y first and then plunge down in Z. If the tool is moving up a surface, it's going to retract in Z and then move over in X, Y to the start of the next cut. Smooth connects the end point and start point of the slices with a curve. And it's not an arc. It actually creates this as linear segments. Your filter might be able to turn it into an arc depending on whether or not you're using the tangent options. And the last one here is follow surfaces. And follow surfaces will try and link the end point and start points and make sure that that motion is actually projected onto the surface. So it will try and always keep your tool in tangent contact with the surface itself. All of these methods are useful depending on the situation you're in. The one thing to note is that when you use follow surfaces, this will automatically disable your tangential options. We'll talk about those in a minute. So this is the section for motion of the tool is less than the gap size. The other section that you'll see is motion of the tool greater than the gap size, retract. And the only real option in this dialog box is to tell Mastercam whether or not you want to check the retract motion for a gouge. Why would we not want to check for gouges? The reason that we may wish to disable those gouge settings is whenever we need to do undercut surface machining. So we kind of covered that in one of our earlier webinars where we talk about using different toolpaths to do undercut surfacing. If you are doing that, we need to disable all of these gouge checks. But we also need to be really careful with our lead in and lead out motion to make sure that the tool isn't going to gouge or hit anywhere that we weren't intending. So those are kind of the basics of the gap motion. Either the tool is going to stay down on the surface or we're going to force a retract. I'll change my gap size up here to 1 inch. By the way, in kind of my standard aerospace machining, my typical gap size would be 0.5 or 1.0, half an inch or 1 inch. And that is kind of a really nice default setting depending on what you're doing. Let's go back to the presentation. So when the gap size is exceeded, Mastercam will retract the tool. I mean, that's the biggest takeaway here with what the gap settings do for you. This retraction varies depending on the style of toolpath you use. So there's only one option here, check the retract motion for gouge. And I say it varies depending on the style of toolpath because the HST toolpaths don't just retract the tool. You can use the kind of shortest distance option and have it output a feed move if you like. So there are some miscellaneous gap options. And well, before we get into those, let's take a look at what this gap can do for us. So I'll set my gap size to 1 inch and let's just set this to smooth. And I'll regenerate that. So now when I look at this, let's go ahead and look at this from the top view. And I'll zoom in down near the origin. And we can see that at the edge of our surface here, Mastercam has now connected the slices or the passes on that surface with a smooth contour. And the tool is staying down on the surface. So gap size defines either the distance or the percentage of step over, and percentage of step over really just gives you a size in the end. But as you change your step over value, it's going to affect your gap size. You need to be aware of that. Now, different settings for keeping the tool down is going to affect the tool path in different ways. This happens to be a fairly simple example. Let's switch to something a little different. This is one of the sample toolpaths that comes with Mastercam. This happens to be one of the X7 sample files that I brought into X8. And this is a surface finish parallel toolpath. I'll rotate this around just a little bit. And you can see that this set of surfaces slopes down. So we start off with kind of a flat surface on top, and we've got a bunch of fillet surfaces and tapered surfaces that go and connect this toolpath. One of the things that you can also see, especially if we go into backplot, as I start to go through this motion, this is our start point. So we have this plunge motion and then as a rapid, it transitions to feed motion, and now the tool is staying down tangent to our surface. And right now it is just making parallel passes. And when it gets to the end of one of these passes, our motion currently is broken. So if we go look at our gap settings, you'll see that motion less than the gap size, keep tool down, and keep it down broken. We're in metric here, so our max step over is 1.2 millimeters. And our gap size right now is defined as a percentage of the step over. Let me unzoom. What you can see is that there are several places on this particular part where we've got some unnecessary retracts. So these are cases where the motion of the tool from the end point of one slice to the start point of the next slice is greater than our gap size. And I can count 1, 2, 3 places where that occurs. So the first thing that I will typically do is come into the gap settings and start adjusting my gap size, either by setting it to a physical distance or adjusting the percentage of step over value. If I set this to 700% instead of 500%, 5 times, now it's 7 times. I'll regenerate that toolpath, and you can see with that setting I've eliminated this retract down here, and I've eliminated this retract here. I'll go back in and make another adjustment because I really want to eliminate that one there. Instead of percentage of step over, let's define it as a physical distance. How about 15 millimeters? If the motion of my tool is less than 15 millimeters, keep that tool down. And you can see that when I do that, I've now eliminated those extra retracts. So if we go in and backplot this, we've got one entry point onto the surface, and we machine the entire set of surfaces, keeping the tool down, not retracting until the very end. This is what I would describe as a clean toolpath, because we don't have any unnecessary retracts. Now we still are running into a situation where we do have this broken motion at the edge of our surface. And what that's going to do is that's going to cause just a little bit of a scallop on this edge here. So one of the things that we can do, we can change our motion setting. Direct would not be good here. Direct would probably cause us to have a little bit of a gouge into our part. A nice flat surface, like that simple rectangle we looked at before, that would be a good candidate for direct. But in this case, let's just do smooth. I'll change my method to smooth, and let's look at this from the top view and fit it to the screen. And if I go and zoom in at the edge of my surface, you can see that Mastercam has created this tangent, not really an arc, it's more of a spline that connects those slices together. So in this case, we are feeding off of the surface. Let me go ahead and reposition. And if we look at this in backplot, you can see here's the edge of a slice, and I'll start stepping through that. And what we've done, let me just rotate this a little bit so that we all can see it. What we've done with that smooth setting is cause the tool to feed off, loop back around, and then continue its cut on the part. So we loop off, come back, and we loop back on. Let's look back in isometric. And let's continue looking at our gap settings here. In addition to smooth, one of the tools that we've got that works with 3 of these different settings is the tangent options. These tangential arc and line options allow us to extend the motion of the surface toolpath beyond the edge of the surface, but only in the direction of cut. So if I go in here and say, let's give it a tangent line of 0.25, I'll go ahead and regenerate that toolpath. And let's look at it from the top view. Oh, pardon me. That's 0.25 millimeters. So let's go in there and say 3 millimeters. Kind of forgot we were in metric. So now what we've done is extended that motion off of the edge, and it does it in a way that's tangent. The problem is when we get into some of these gaps, if Mastercam can't quite figure out the tangency, it will give you part of the loop and then it just kind of defaults to broken. So that can occur especially when you start using larger and larger tangent extension values. Now, in addition to being able to extend it with a tangential line, we can also extend a tangential arc off of the surface. And this can be useful, especially I find with the smooth option, to have the tool motion come off the surface, retract up, and then come back down and back on. So let's look at this. If we're using the arc options, we have to use the tangent arc radius and the tangent arc angle value. Let's set our line to 0, and let's set the tangent arc radius to 10 millimeters, just because it makes it easy for us to see, and tangent arc angle to 90 degrees. What this does is this creates what would be considered an arc that comes off the edge of our surface. So we come off the edge of our surface with this arc, and then we create a smooth loop to come back down. I'll go back in and change that. Let's make that a 3 millimeter tangent arc. That looks a little better. And keep in mind, this isn't really an arc because the motion as we come across this surface is not planar. If we look at this in the top view, it's planar in this direction, but the surface itself is angled. And you can see if we come in off the edge of the surface, this is more of the result you get off of a flatter surface. It looks a little better. And you can also combine the tangent line with the arc. So if I add a 3 millimeter tangent line with a 3 millimeter tangent arc, we can extend the motion off, arc up, move over in a smooth arc, and then arc back down onto the surface. Keep in mind when you do this, you can get some kind of interesting results depending on your gap size. So we've told it 3 millimeter extension, 3 millimeter arc radius. In this case, because the gap size itself is so much bigger, the smooth motion creates a much bigger transition there. So you just have to be aware of these settings and play with them until you get them right. So right now we're using a 90-degree tangent arc angle. Let's change that to 45. And instead of doing a full loop up in a 90-degree motion, now we come out with our line and we only complete about a 1/8 of a circle before we move over with the smooth and move back down to the start of the next slice. Again, if it has trouble calculating that tangency, it will default to broken. Okay? Now, this can also, depending on your gap settings and the toolpath you're using, get you into some trouble. I'll save that file and let's go back to the other one we were looking at. This surface is really simple. It's nice and flat, so we can extend tangent depending on what's in the way, of course, and everything works out well. Let's look at something that's a little different. Okay, if we've got kind of a complex contoured surface, especially with some holes in it, we have to be a little bit careful about our gap motion. So I'll take this toolpath and apply it to this surface instead, and I'll regen it. Pardon me. So now we can see that we've got some areas where we're driving and we're still basically just tangent to that surface. We've got a couple areas where we've got some broken motion. We've got one here. And then we have the motion on these holes as well. So if I go back in here, I'm using a 1-inch gap motion, and I've got my motion less than the gap size. I would think of this as the keep tool down setting, set to smooth. I'll set this to follow surfaces, and now let me increase this gap size to, say, 3 inches. I can do that, and depending on, you know, the size of the motion here, it looks like it's over 3 inches because we haven't eliminated this one. So if I go back in here and say, you know what, let's do 10 inches. Let's give it a big gap size. I have now eliminated that retract here. But I've also set my gap size so high that we are now falling into that hole with my tool. So you have to be a little bit careful about how you manipulate those gap settings. And in addition to our gap settings, we also have this advanced settings button over here. The advanced settings control the rolling of the tool at the surface or solid face edge. And if we go look in the Mastercam help file, there's a good example of this. So when I click on About Tool Roll Motion, we get this nice little description here. Here's a case where we've got two half-circle, hemispherical, or half-cylinder surfaces. And the setting is only between surfaces. What's happening is we're starting a cut on this surface, and then we're rolling up and over that surface edge into the slice on the next surface itself. If we use over all edges, Mastercam causes that tool motion to roll over all of the sharp edges of the surfaces. So this can be another one where we can get into trouble depending on our setting. If I say at the surface, solid face edge, roll the tool over all edges, and we regenerate that, and I look at this, say, from the front view, you can see that over all the edges of the surface, Mastercam is taking that tool and rolling it all the way over. So in that case, it rolls it all the way to the tangent point of the ball. So with those gap settings and a combination of those and the advanced settings, we can really control the motion of the tool. Now I do want to show another way that we can think of applying gap motion and using it to our advantage. So I'll go ahead and turn the toolpath display of that one off. We're going to look at a different part. Let's turn off our complex surface. Here's kind of a typical thin wall aerospace type part. And we've got a situation where we've got a couple of angled walls and a flat floor surface with a couple of different fillets of different sizes that blend in here. What I've done is create a roughing toolpath that's an OptiCore. Go ahead and turn all these on and set it to only display selected toolpaths. So I've got this nice OptiCore roughing toolpath. I've got a high-speed horizontal, which is finishing this flat area here and this flat area on top. And I've got a 2D contour that finishes the inside window here. And then a surface finish flow line, which comes and finishes these ramps here using a flat end mill, because I can get away with that. And the result that we're left with is my stock model here. So I've made a stock model, and we can see that it's basically finished. The whole part is finished, except for this area on the inside of the wall and this flat area here. And I'll go ahead and turn off the toolpath display here. Let's do this. Let's also make our solid blue. So I've got a situation here where I've got some material that's left on this wall and on these two fillets and just a little bit on the floor. So what I'd really like to do is be able to do a zigzag pattern on the floor where I only have to remove a little bit of material, but then transition to being able to finish this wall as well. So here's how I'll do it. I'm going to go select the Solids tab in the Operations Manager, and I'm going to move my stop operation up. And the reason I'm moving my stop operation up is so that I can get to this solid before the fillets were put on. I'm going to change my wireframe color here to red. And I'm going to use Create Curve on one edge. And I'll put a line here and a line here. Then what I'm going to do is move my stop op operation all the way back down to the end. And if I go in and turn off my solid level, actually let's just do this. I'm going to select all wireframe and then do hide, which is Alt-E, to get rid of all that stuff. What I'll do now is use my trim and break. So I'm going to do trim, break, extend. I'll set my distance here for, say, 0.75, 3/4 of an inch, and set my mode here to break, and I'll click on that line. Ooh, sorry, I want minus 0.75. So I've now broken that line 3/4 of an inch back from the end point. What I'll do next is Xform offset contour, and select that contour there. And we're going to offset it by our finish pass. So I'm going to use 0.005. I'll do a 5,000th finish pass. And I'll hit apply. And then I'm going to select that contour again, the new one that I just offset. And we're going to offset it by whatever our step over value is. Let's do 3 passes at, actually let's do 2 passes at 10 thousandths. And then I'm going to do one more offset of the very farthest contour there. Let me do motion controller rotation position. There we go. I'm using a space mouse, by the way, Space Pilot, to be able to move this around a little bit. And we'll do these guys, we'll say we want 10 passes at 0.02. And over here, I'm going to shave just a little bit off of there. So we'll do Alt-E again. There's our fillet blending in here. Here's our offset chains. And that actually looks okay. So what I'm going to do is create a surface high-speed project toolpath. So I'll do toolpaths, surface high speed, and we'll do project. And it says select drive surfaces. I'm going to go activate my solid selection and make sure that faces are selected. I want to select all those surfaces there. And we're going to go ahead and end our drive surface selection. And now I'm going to choose my curves. I'll look at this from the top view. And what I'm going to do is select these curves out here using the vector selection method. And vector is nice because I'm going to drag a vector across these curves. And what it will do for me is select them in an alternating fashion. So I'll select vector. I'm going to drag a line. So I clicked and dragged to start my vector line, and I'm going to continue it across to there and click. And then hit enter. And what Mastercam has done is selected all of those chains for me. When I click OK, if I now click on the curves selection dialog box again, what happened is it selected this curve going to the left. It came all the way to the end of that curve. There's the end point, and it selected the next curve it could find going the opposite way. So what I'm going to do now is take a couple of these chains and just reverse them. So I'm going to use my select button, and I'll click on this chain. It shows me that it's chain 12 in the list, so I'll right click on it, and we'll say reverse chain. Then I'll use my select button again. Select this chain here. It shows me it's chain 14 in the list. I'll right click and do reverse chain. So now when I look at my curves, I am zigzagging back and forth until I get up to the last few passes, and I'm going to take those going one way. So now what we're going to do is go create, actually we'll just select the library tool, and I'm going to use, I believe it's an 0.625 radius, so I need a 1/8 ball. So I'll grab a 1/8 ball end mill, and we're cutting curves, and what we want to do is set our keep tool down within to be less than the distance between our one-way curves. So let's set our keep tool down within a distance. Well, let's set that to say 0.25. So any motion in the gap that is less than 0.25, we're going to keep the tool down. Any motion that's greater than that, we're going to allow the tool to retract. And we'll set the drive stock to 0 here. We can do smooth on the transition. That's going to be okay. And everything else we can leave with the defaults. And what we end up with, oh, we should take the smooth off. See, smooth is causing it to dive down into our cavity here. It does a nice job over here. But let's go adjust that a little bit. So if we use the straight transition, it works a little bit, still rolling over this edge. So how could we prevent it from rolling over that edge? Well, one thing we could do is just to create a nice flat surface to kind of contain that motion. So what I'll do from the top view, I'm going to select my Z depth off the corner of my model. So look at it from the top view, and I'm going to do create rectangle, and I'll turn on create surface, and let's create a surface that looks something like that. Now what I'm going to do is add that surface to my toolpath. And in the parameters, we'll go back to the smooth transition. And that looks a little better. Now the other thing that I can do is shorten up these lines a little bit. So the last thing that I'll do, edit, trim and break, and we'll set this to say minus 0.25, and we'll set that mode to trim. And I'm going to cut back these lines, and let's set this to minus 0.18, and I'll trim back those lines. And now when I regenerate, get some pretty nice motion. So just something to think about and be aware of. Because the distance between our project chains is less than our gap size, it's keeping the tool down. And anywhere where it gets bigger than that, it just allows the tool to retract. Okay, so that's going to conclude our demonstration of gap settings. We're going to go ahead and open it up to see if anybody's got any questions.
Thanks, Colin. Okay, everybody, now's your chance. If you have questions, go ahead and type them into the questions box, and we'll cover as much as we can in the time we have left. So I have a question coming in from Gerald. Is this the same, all of these gap settings, are they the same in X7 and X8?
They are the same between the different versions of Mastercam. but there are different behaviors depending on whether you're using the legacy toolpaths. So if you go to Surface Rough or Surface Finish, these are what I consider the legacy toolpaths. And those toolpaths haven't really changed much in the terms in the respective gap settings or advanced settings since version 9. Now what's changed is that Mastercam has now added the Surface high-speed toolpaths, and this has some different retract behavior because you don't get all those gap settings like you do with the legacy style toolpaths. If you look at the newer toolpaths, really all you get is straight or smooth. So you have to be a little bit more careful about how you apply the Surface high-speed toolpaths in some cases. And in some cases, the Surface high-speed toolpaths are going to be your best solution. And in other cases, you're still going to want to go back and use those legacy Surface toolpaths. I mean, Surface Finish Flowline is still one of my favorite toolpaths. You'll see me use it all the time because it's got those options for the gap settings where some of the new toolpaths don't. So you just have to be a little careful in which one you choose. Good question, though.
Right. Okay, and then one, this is really referring back to the demo, came in a couple minutes ago from Frank. The comment here while you were doing the demo was that the toolpath was not cutting up the angle, not following the wall.
Well, with project, that's the way that it works. If we go and look at it, we are taking that tool and projecting it. So one of the things that I probably should have done, these are all of these contours right now are centerline contours. What I should have done was offset the first contour by the radius of my tool. Because what's happening is as we get, let me turn off the holder here. As we continue this motion, this all looks good, but you can see that I'm getting close to the tangent point. There's where we're basically tangent, and we're actually machining that correctly. So my issue here, and he was right to notice it, is that I've just got some other geometry that's too close to my wall that shouldn't actually be included. So if I hold down Shift, see where that. Let's see where we're tangent here. So right here, all the rest of these parts of the contour really shouldn't be included. But that was a good catch.
Got it. Okay. Let's see. A question coming in for Joseph. Are we able to set up lower safe distance movements if they were needed in this toolpath?
Not sure what you mean by that. We do have, especially which toolpath, the project or the old style. I mean, we do have some depth limits, but the problem that we saw when we first did this Surface high-speed project is that there's really no way to control it dropping off the edge of the surface unless we try to set a depth limit. So we can try that. Let's do this. Let's get rid of this surface, regen the toolpath, and we should see it drop off. But if we use the Z depths, it's 0.1, 0.1. Yeah, you have to be a little bit careful. Let's go 0.09 to 0.11. And it will kind of control how it drops off the edge, but not really. So it makes it a little bit better, but no, that's about the only control you get. I mean, there are different depth controls, but they're kind of treated separately in my mind from the gap settings. I mean, gap settings is all about, does the tool retract or not?
Mm-hmm.
Good
Okay,
question, though.
fair enough. And then those depth settings, you just were basically setting a range there for that minimum and maximum depth, just in between
Yes.
those two values. Okay,
Yes.
very good. So, Joseph, if you want to follow up, if you have a follow-up question to that, just go ahead and type it in. Let's see, I have a comment from Jersey. Thank you for a nice show. And Jersey, I know I've been speaking with, so we're gonna say hello to Jersey out there at the IMTS show, and I should just go ahead and mention Colin and I will be out at IMTS, so any of you guys, if you want to say hello, give us a shout, and we'll make a connection at the IMTS show. Let's see, William is asking if he can get a copy or a link to this recording. So the answer there for everybody is yes. I will process the video and post it up within the next 24 hours, and we will send everybody on this, everybody who's registered for this webinar will get that link in your email. Clifford says, really nice to learn how to extend past edges. Thanks, Colin. Well, thank you, Clifford, for being here. Let's see, Frank has a question or a comment. Let's see, the previous example with gap settings set to smooth. Most of the arcs were correct, but there are some where the arcs end up with a Z move followed by a straight line.
Mm-hmm. Yes, what's going on there is that the tangential options, when you're coming off of a set of surfaces like that, can't always figure out exactly, what the right motion is, and a lot of times it's trying to approximate not only the tangent extension, but then the smooth settings on top of that. So what happens is part of the motion gets defaulted to broken. Basically, if it can't do your smooth connection, it's going to default to broken because the algorithm runs, it tries to calculate all of these different tangential positions, and it just says, you know what, I got pretty close, but the end point of the calculation for my smooth linking ended up here, and then start point's over here, and it just defaults to broken. So you kind of need to play with those settings and massage them to get what you're looking for, And the other thing is, do you really need 90 degrees of tangential arc? A lot of times I'll try and go with like a 20-degree sweep. So I'm just barely retracting up off of that surface. Now, if you really want to get really clean, good tangential motion, you need to extend the edges of your surfaces so that Mastercam's got something that can actually be sliced by the algorithm, and by extending your surface a little bit, now you've brought the edge of the tool off the edge of the surface, and you can either ignore those tangential settings or use a small value. The smaller values that you use on some of those surfaces, the cleaner the result's going to be. I can show that just a little bit real quick. I know we're running out of time here. But again, I think this is kind of what we were talking about. If we go back in there and we say, all right, instead of, why don't we just do a line? Let's eliminate the arc out of it and see how much it improves. Because remember, we're still doing smooth. So this is just an area where it's having trouble calculating that tangent extension. Maybe a lesser value would help. Let's go 1 millimeter instead of 3. It improved it, but sometimes you have to live with what you get. If you really wanted nice, clean tangent extension off of here, extend the surface. I think that's that's part of it. This is all trying to give you the best of both worlds, allowing you to extend off of this. But this isn't this works really clean on a nice flat rectangular surface. But when you've got a surface that is angled and curved in multiple directions, I mean, honestly you're kind of asking a lot from the software in some ways. So there are some times where the older legacy paths are more appropriate, and there are some times when those newer surface toolpaths are your better bet.
Right. And I think I would just add to that every new piece of geometry, every new part you do is going to have its own complications. So there's not one size fits all. There really is a lot of skill to being a good 3D programmer and understanding all the tools that you have in your tool belt to get the best result that you can. Okay, well, we'll keep it going here because we're overtime here. It's lunch is over on the West Coast. Time to get back to work. Let's see if I've got a couple questions coming in. Booth number for IMTS coming in from Ken. Colin and I will both be in a couple different booths during IMTS. We're both kind of CAD-CAM people, and we don't always subscribe to just one CAD-CAM system. So we'll be around in a couple different booths. So the best way to get a hold of us and meet up is to send us an email, Derek@eapprentice.net, that's D-E-R-E-K at eapprentice.net, or Colin@eapprentice.net. And let's just make an appointment and we'll meet you. We'll grab a cup of coffee or meet you at some certain place in the hall. Let's see if Al has a question on tangential arc rad. You said you can use with 3 gap settings. Which ones?
The only one it doesn't work with is follow surfaces. So direct, broken, and smooth will allow you to do those.
Okay, fair enough. And I have just lots of comments. I'm trying to just pick out the questions. We've got a lot of people saying thank you, and I would like to say thank you right back, because we appreciate the fact that you're spending an hour with us out of your busy day and working on this. So with that, I think I'll close this out for today. Hopefully we'll see some of you out at IMTS. We'll certainly see you out on the next webinar. Colin and I are refocusing in on eApprentice, and these will be held on a monthly basis at the very least, if not more. So checking out for today, check your email within the next 24 hours and I will give you a link to this webinar recording so you can stash it away and save that knowledge for future use. So thank you, Colin. Excellent presentation as usual, and we'll see everybody later.
Thanks, everyone.
Thanks. Bye now.